This is the fourth and final video on further factorization. In this video we're going to consider adding and subtracting algebraic fractions. So let's look at numerical fractions. Let's look at 2/3 plus 1/5. So we should recognize that the lowest common multiple of 3 and 5 is 15. So we multiply numerator and denominator by 3 to get 15 there, and 5 and 5. So we get 10 over 15 plus 3 over 15. And that could be written 10 plus 3 all over 15, which is 13 over 15. We do exactly the same thing for algebraic fractions. Say we get a over b plus c over d. The lowest common multiple, let's box that, the lowest common multiple of bd is bd, because bd divided by b is d, and bd divided by d is b. Remember your definitions of factors. If it divides perfectly, it's a factor. So we multiply everything here by BD. So what are we left with? We are left with ABD over BBD plus CBD over DBD. We need the fraction to be out of BD. So we can see that the B's cancelled here. There's a bit of a mess there. Let's rewrite that as DBD, and the D's cancelled here, and we are left with AD plus CB all over BD. Now there's a much quicker way to achieve this, and it's called cross multiplication. Because there's cancellations involved, we can just cross multiply. We have A over B plus C over D. We can do cross multiplication, AD plus BC over BD to get the same result. And the same works for negatives. So you have a go at adding A over B minus C over D. Pause the video. So hopefully you've done that now. So we get AD minus BC all over BD. So let's have a look at some questions. Okay, so I would like you to write as a single fraction, so express as a single fraction. So let's get a nice easy one. Let's do 2x over y plus 3x over 2y. Let's do x plus 1 over x plus 2 plus 2/3. Let's do 5 over x plus 3 plus 4 over x negative 2. So we just treat each of these as if they're a over b and c over d. So for instance, on the first one, we can let a is equal to 2x, b is equal to y, c is equal to 3x, and d is equal to 2y. And just use our results. A over b plus c over d is ad plus bc all over bd. It's exactly the same process. So pause the video and see if you can have a go at doing each of these. So hopefully you've done that now. So we cross multiply and we get 4xy plus 3xy all over 2y squared. We can take out an xy to give 4. We can add them actually to give 7xy all over 2y squared. We can cancel the y's, that goes. So the final answer is 7x over 2y. And I would leave it in fractional form. So let's cross multiply then. So we've got 3x plus 1 plus 2x plus 1 all over 3x plus 1. We factorize before we cancel. So we can combine these to get 5x plus 1 all over 3x plus 1. That goes, and you're left with 5 over 3. Alternatively, we could have just cancelled straight up and got 1 plus 2 over 3. That's 1 over 1. Cross multiply 3 plus 2 over 3, which is 5 over 3. Okay, so let's do the final one. We're going to cross multiply. Nothing's common, so we use the distributive property. And we are left with 9x minus plus 2 over x plus 3 and x minus 2. Okay, so hopefully that is clearer. So let's finish on a complicated question. Again, the trick to solving these questions is practice. Practice brings about understanding, and fluency helps you to complete the problems. So the last one is simplify this expression. Okay, so it's a little bit tricksy-dixy. There's a lot going on there. So pause the video and see if you can write that as a single fraction. So simplifying in this context means write as a single fraction. Okay, so hopefully you've done that now. This is a difference of two squares. And you can notice here that we have a x subtract 3 and we've got a 3 subtract x. Now this is a trick which is used throughout maths. If we multiply the numerator and the denominator by -1, we get what we want. As long as we do the same to both numerator and denominator, we do not change the fraction. So let's do that then. So we're going to get -1 all over x subtract 3. Okay, so we need to find the lowest common multiple of the denominators. So we need to make all the denominators equal to this difference of two squares. So we need to multiply this one by x plus 3, this one by x subtract 3, so that now becomes x subtract 3 all over let's apply the distributive property there. We're just going to get x subtract 3 plus 6 subtract x subtract 3, and looks like you can get 0 for this. That goes, that goes, that goes, that goes, that goes 0, so we get 0 over x subtract 3 x plus 3, so that just gives 0. In maths we're allowed to have 0 on the numerator. This is not allowed. This does give 0, that does not give 0. Okay, so lots of maths going on there. So good luck, and if I can encourage you to complete every question in the textbook, that will bring about understanding through fluency and practice.